Hi, welcome to my video on proofs with converses. Proofs with converses. Let's do some examples, and if you wish you may pause your video and work them out before me, your choice. We have a diagram with two lines, A and B, transversal T intersecting these two lines, forming 1, 2, and 3 angles. And more angles, but I just named them that way. And we're given that 1 is supplementary to 2, and we have to prove that A is parallel to B. So to prove parallel lines, we need a pair of angles equal or the same side supplementary. So we need angles equal. So we have supplementary, so let's write down the given first since there's only one given. Supplementary, angle 2 is supplementary to angle 1 given. And look around and we have another pair of supplementaries. Angle 2 and angle 3 are a linear pair, and that's the definition of linear pairs, in that if two adjacent angles form a straight angle, then they're a linear pair. And because they are a linear pair, that means 2 is supplementary to angle 3 because they form a straight angle. A straight angle is 180 degrees, so we have a straight angle. Notice that 1 is supplementary to 2, 2 is supplementary to 3. As a result, angle 1 is equal to angle 3. And supplements of congruent angles are congruent, so we call it the SAT, done in previous video. Supplement angle theorem. Supplements of congruent angles are congruent. Number 5, 1 and 3, notice, are alternate exterior. So we have A parallel to B, and it's called the converse of the PLT. And that's alternate exterior angles equal. So again, the lines are parallel because the alternate exterior angles. Number 2, look around the diagram. See the diagram? We're given 2 is equal to 4, and I see vertically opposite angles here and here. We want to prove that A, B, C is isosceles. To get an isosceles triangle, we need two sides equal. So if this is isosceles, it looks like that AB is going to equal AC. And there's no congruent triangles, so I'm going to have to get these two sides equal. Oh, if I can get angles 1 equal to angle 3, then these sides will be equal by the converse of the ITT. So here we go. I have a plan. So angle 2 is equal to angle 4 given. And angle 1 equals angle 2. And angle 3 is equal to angle 4. And it's called vertically opposite angle theorem, or VAT, your choice. Vertical angle theorem. And that's if two lines meet, then the vertically opposite angles are equal. And number 3, that means that angle 1 is equal to angle 3. And that's because of transitive property. And as I say, there's 2 of them there. If 2 equals 4 and 1 equals 2, that means 1 is equal to 4. If 1 is equal to 4 and 3 is equal to 4, 1 is equal to 3. Transitive property twice. And we have the two angles equal in the triangle, so that means that AB is equal to AC, and that's the converse of the ITT, which means if two angles are equal, the sides opposite those angles are equal. And as a result, because the two sides equal, the triangle ABC is isosceles. And that's the definition of an isosceles triangle. Okay, let's try some more. Again, you can pause the video and work these out before I do, your choice. Or you can follow what I'm going to do. We have a diagram. We're given that angle 1 is equal to angle 2. This angle is equal to this one. We're given that angle A is equal to angle C, which is these two. Notice I got the first one's marked with 1 stroke, the second one's marked with 2 strokes. We want to prove that TA equals VC. So, how do we do it? We've got no congruent triangles, so if these two angles are equal, then PT is equal to PV. And if angle A is equal to angle C, that means PA is equal to PC in this triangle here. And if you can see that TA and VC are the smaller segments. So I got PA, the large segment, I got PT, the small segment, so if I subtract, I'll get TA. So, there we go. Angle 1 equals angle 2, given. And as a result, I got PT equals PV. And that's the converse of the ITT. Number 3, angle A equals angle C, given. There's a dot there. And that means that PA equals PC. In this triangle here, these two angles equal, these two sides are equal. And again, that's the converse of the ITT. Number 5, PA is equal to PT plus TA, and PC is equal to PV plus VC, and that's a 4 there. That's the segment addition, ADD, segment addition property of equality. Just write that down. So if you said the segment addition property, would your teacher give you credit, or do you have to say off equality? Check with your teacher. And notice that we have PA is equal to PC. There's PA, PC. That means if PA equals PC, that means that this is equal to this. So PT plus TA is equal to PV plus VC by transitive property of equality. And notice that PA is there, PC is there, so if these are equal, these are equal. Now we have that PT is equal to PV, so that means that TA is equal to VC by subtraction. PT equals PV, PT equals VD, PT equals PV, so subtract them, and I get TA right here equals, you're subtracting PT and like that of each side. So that's the subtraction property. Again, you could say off equality or just subtraction property. Again, check with your teachers. Do you have the right off equality down each time? That's done. Number 4. Let's look around. We always like to look at what we are given. So PQ equals PR. So PQ equals PR. There it is. We got TR, which is this one, equals TS, which is this one. So I got a mark. Notice I marked these with 1 stroke, and this one, these two with 2 strokes. I want to prove that PQ is parallel to TS. So PQ is parallel to TS. To get parallel lines, you need angles equal or same side. The interior angles are supplementary. So if I have, how do I get equal angles? Well, I notice that 3 is equal to 1 and 3 are equal by vertically opposite. So if these two are equal, then that means means these angles are equal. If these two sides are equal, that means these two angles are equal. So it looks like I'm going to put a 4 here and a 5 here, just to make it easier. Instead of going P, Q, R, and T, S, R, put 4 and 5 in the diagram. Again, check with your teacher to make sure you're allowed to do that. So you put 4 and 5 in, then it's easier to name the angles. So we have it. Let's go. Again, these two angles are equal, ITT. These two angles are equal, ITT. These two angles are equal by vertically opposite, hence 4 is equal to 5, transitive, and we got the parallel lines. So number 1, PQ equals PR, and a given. Now I'm doing the givens separate. I could put the two givens right here, but I'm doing one of them to get to one pair of angles, and that's the ITT. Then I'm going to do the other given, that TR equals TS, TR equals TS, given. And that gives us angle 3 equals angle 5. And again, Isosceles triangle theorem, which means the two sides are equal, the angles opposite those sides are equal. Now we have 4 equals 1, 3 equals 5, so we have to connect them. So angle 1 is equal to angle 3 by VOAT, or VAT, vertically opposite angle theorem. If two lines intersect, then the vertically opposite angles are equal. That means that we have angle 4 equals angle 5, and that's the transitive property of equality, and we have to do it twice. Again, 4 equals 1, 3 equals 5, 1 equals 3, so they're all equal, so that means 4 is equal to 5, transitive property. And as a result, we have these two angles right here equal, and the line PQ is parallel to TS. Why? Because these are parallel lines. If you have a transversal QS, these are alternate interior angles equal. So that's the converse of the PLT, and it's alternate interior angles equal. And that proof is done. Again, hopefully you're following the strategies. You have to look at what you're going to prove, and you have to look at what you're given. And again, you try to do the proof beforehand and then write it up after. So if you can do that. Let's see, we have the diagram. We have T is equal to 2, so we have angle T is equal to angle 2. And right away, as a result of that, these two angles equal. That means I got these two sides equal. O is the midpoint of TW. O is the midpoint of TW. That makes these two segments equal. Definitely. If we want an isosceles triangle, we need two sides equal. So XOW is going to be isosceles, so we need two sides equal. So it looks like these are the two sides. So here we go. These two are equal. These two are equal by midpoint. That means if these two are equal, these two, TO equals OW, then we have OX equals OW, and we have an isosceles. So here we go. Angle T equals angle 2. Oh, I didn't write the statements. If you do your own proofs, you're going to say statements and reasons. So that's a given. So if those angles are equal, that means that OT equals OW, and you're going backwards from angles to sides, the converse of ITT. Number 3, O is the midpoint of TW, and that's a given. And as a result of that midpoint, that means OX equals OW, and that's definition of a midpoint. And as a result, if OT equals OW and OX equals OW, that means that OT equals I got two sides equal, so OT equals, that's an OX. These are the two sides that are going to be equal. That's an OX there, my mistake. And because of midpoint, then that OX, again, one stroke is equal to this one. So that means that OX equals OW. OT equals that, okay? OT equals OW. Now, I get that equals that, and that equals that. So therefore, they equal. So OT equals OX. OX equals OW. So that means that OT equals OX? No. One of those things you lose it for a second. OT equals OX and OX equals OW. How can you say that? Oh. See, just a little mistake. OT equals OW. OT equals, when I did the midpoint, I said OT is equal to OW, but I didn't put it down. Now that means that OT is common, so we got OX equals OW by transitive. I knew I had it right, but it was just, I said something, transitive property. So OT is here twice, so OX equals OW. Sorry about that. I knew I had it, but I wrote down the wrong ones. Just be careful. Doing a proof is easy to make a mistake. And number 2, we have to prove we have PQ equals PS. We have SQ bisects angle PQR. SQ bisects PQR. So there's two angles here. So I'm going to make this angle 1 and angle 2. Instead of going PQS and RQS, let's call them angle 1 and angle 2. So I have these angles equal because of the bisector. And how do we get? We get the two sides equal. That means that angle 1 is going to equal this angle here. Let's call it 3. Instead of going PSQ and PQS, use the numbers. So I got 1 equals 2, 1 equals 3. So that means 2 is equal to 3. That means the lines are, these angles are equal. The lines are going to be parallel. PS is parallel to QR. So we have it. PQ is equal to PS. A given. And again, the first column is the statement column. And the second column is the reasons. And because PQ equals PS, angle 1 equals angle 3. And the reason is ITT. Two sides equal, two angles equal. And we have a bisector. SQ bisects PQR. And that's a given. And the bisector of an angle forms two equal angles. So angle 1 is equal to angle 2. Definition of an angle bisector. If you bisect an angle, you cut it into two equal parts. 1 equals 3, 1 equals 2, so that means angle 3 is equal to angle 2 by transitive property of equality. And because we have these two angles equal, that means that PS is parallel to RQ, and these angles right here are equal. So that's a one stroke, that's a one stroke, so this has got to be a one stroke too to be equal. Can't put two strokes on that because these are equal. And so that's why They're alternate interior angles. So it's the converse of the PLT, alternate interior angles equal. Okay, there we go. Some more proofs. Again, pause the video and see if you can work these out. Now, what do we have here? Let's see. 1 is equal to 2. 2 angles equal. That means these angles are equal. That means we can have this side FE equals GE. We have IF equals, so IF is equal to GH. And how do we get these two equal? I know I have these equal. How do we get angle 3 equals angle 6? Well, these are supplementary, linear pair. These are supplementary. So that means if I want 3 is equal to 6, so I have to get 4 is equal to 5. And how do I get 4 equal 5? Well, this segment right here is equal to this one. And this segment here is equal to this one. So if I add these together, I'll get the big segments equal, IE and HE. And therefore I'll have 2 sides of a triangle equal. 4 is equal to 5, and then I get 3 is equal. Oh, okay, we have it. Angle 1 equals angle 2. Given. That means that we have FE equals GE, and that's 2 angles equal. That's the converse of the ITT. 2 angles equal, 2 sides are equal. And we have IF equals HG given. And if I add these together, so if I take FE and add on IF, so IF plus FE, and take HG and add on GE, that's the addition property. Addition property of segments. And, oh, that's just addition property, not of segments, sorry. Addition property, we're adding them together. Now we have IF plus FE equals IE, and we have HG plus GE equals HE. So these two segments will add together to give you IE, and these two will add together to give you HE. So that's the segment addition property. So as a result, IF and FE are right there, and HG and HG and GE are right there. So these two are equal to these two. Since they are right there, that means that IE equals, IE, gotta be careful, IE equals HE, and that's the transitive property. Just gotta be careful now. We're adding the segments together by addition. Segment addition ties these two up to give us the big ones equal, and that means that if IE equals HE in this big triangle here, that means angle 4 is equal to angle 5 by IDT. And we have, what we have now is that angle 3 and angle 4 are a linear pair. Angle 5 and angle 6 are a linear pair. And that's definition of a linear pair. And as a result, we have angle 3, angle 4 are supplementary. Angle 5 and angle 6 are supplementary. That's because of a straight angle. And what happens, because 4 is equal to 5 and they're supplementary, that means angle 3 is equal to angle 6 by SAT. Supplements, two pairs of supplementary angles with a pair equal. Supplements of congruent angles are equal. We did the proof on that earlier. 3 equals 6. And we have another proof to do. Hopefully that makes sense, but you just got to be careful here. Adding these together by addition property, and then we have the segment addition, which ties these two segments together by getting the big ones. Just be careful. And number 4, angle 5 equals angle 6. Angle 2, 2 strokes, equals angle 3. And we want to get that AB equals AC. AB equals AC. So to get these two sides equal, I need the property to get 1 equals 4. So 1 is equal to 4, then these angles are equal, converse of ITT. But to get 1 equals 4, I have to go with, let's see, I got these pairs of angles equal. Let's put a 6, that's 1, 2, 3, 6. Let's put a 7 right here. TBO is 7, and PCF is 8. So let's, rather than use the 3 letters, let's use these numbers. So if I have these two angles equal, that means these third ones are equal. I did a proof in a previous video. If two pairs of angles of one triangle are equal to if two angles of one triangle equal to two angles of another, then the third ones are equal. And since 7 equals 8, then these are VOAT, 1 and 7 are equal, 4 and 8 are equal VOAT. That gives us transitive that 1 is equal to 4, then the sides are equal. Okay, here we go. We have it. Angle 5 equals angle 6. Angle 2 equals angle 3. Given. And as a result, angle 7 is equal to angle 8 if two angles of one triangle are equal to two angles of another triangle, then the third angles are equal. Okay, so now we have to connect up. Angle 1 is equal to angle 7. Angle 4 is equal to angle 8, and that's VOAT or VAT, vertically opposite angle theorem. Pair of lines intersecting, vertically opposite angles equal. This pair of lines AP intersects TF, so these vertically opposite angles are equal. And as a result, we have angle, if 7 equals 8, 1 equals 7, 4 equals 8, then angle 1 is equal to angle 4. Transitive property of equality. And we got 1 equals 4. That means that AB is equal to AC. And that's two angles equal, so it's the converse of the IT, working backwards. ITT is what? If you have two sides equal, then two angles are equal, that's the ITT. Converse, if two angles are equal in a triangle, then the sides opposite are equal, that's the converse. And that did a few proofs for you to show you about converses, how they work. Okay, hope you enjoyed the video. And if you did, click the like button, subscribe button, notification bell. Visit my math website, www.mathfullyexplained.com, to find more information from me, my videos, and the content. And that's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.